Hey, ladies and gentlemen. So today what we are doing is going to look at the formative one that we took on Tuesday. Sorry, not Monday. We took this one on ionic and covalent naming. All right. So if we look, the first thing we probably want to do is figure out which ones are ionic and which ones are covalent. So if we look at this one, we have strontium, which means this is going to be an ionic compound because it's metal, strontium. The second one has prefixes in the name, which automatically tells us it's going to be covalent. Otherwise, we can't tell that phosphorus and oxygen are both nonmetals, which is also telling us covalent. The third one has cesium, which means it's again ionic because it is a metal. Astatine and fluorine, arsenic and fluorine. I keep thinking astatine for some reason. Arsenic and fluorine are both nonmetals because they're on the right side of the metal-like line, which means they're covalent. Platinum, again, is a metal, which means it's ionic. We also have a Roman numeral, which only happens in ionic. Nitrogen, hydrogen, and bromine are all nonmetals, but NH4 is a cation. It's a positive polyatomic ion called ammonium, which makes this ionic as well. Oxygen and fluorine are both nonmetals, making it covalent. And nitrogen and oxygen, again, are nonmetals, so it's covalent. So just identifying those helps us figure out when we need to use prefixes, when we need to use Roman numerals. We need to look at polyatomics. Excuse me. So we have all these. The first one is ionic. So we need to look at the charges. So we have strontium, which is SR with a +2 charge. And we have phosphate, which is PO4 with a -3 charge. All right. So one way to look at this is trying to figure out how many of each do we need to add those charges up to 0. So right now, if we add our charges up, we have 2 minus 3, which gives us -1, which is not 0. So we have to add another positive. So we have strontium, we add another one, and now we have 4 minus 3 equals 1. So now it's positive, which means we have to add a negative sign, giving us PO4 with a -3 charge. But now we have 4 minus 6, which gives us -2, which means we have to add another strontium, making it 6 minus 6 equaling 0. So now we can tell that there are 3 strontium, so SR3, and we need 2 phosphates. So we got to put parentheses to show that we need 2 full sets of phosphate, PO4, 2. And that is our compound or our formula. The next one, diphosphorus pentoxide. So di means 2, and pent or penta means 5. We have phosphorus and we have oxygen or oxide because it's the second element. And so now we can put it all together. We have P2O5 as our answer. All right, now we have cesium 2SO3. And that one's ionic again, which means we have to figure out the metal first, which is cesium. And because cesium is in the first column, means it has 1 valence electron and it can't have more than 1, which means it just stays as cesium. And then we look for SO3. SO3 is going to be sulfite. Remember, SO, you have to look at the subscript. The number 3 or the number 4 tells you if it's sulfate or sulfite. If there was no O, then it would be sulfide, but we have sulfite here. All right. The next one, arsenic and fluorine. There are 5 fluorines. So arsenic, there's 1 of them. And so remember, the first element, if there's 1, doesn't get the mono, but the second one would. So it's arsenic. And it doesn't get a mono because it's the first element, and we know that there has to be at least 1 of those. And then fluorine turns into fluoride because the ending's got to change. So it becomes fluoride because we have to have the second element end in IDE. And because there are 5 of them, we get the prefix penta. So it becomes pentafluoride. So it becomes arsenic pentafluoride. The next one is platinum 4 manganate. So we have to remember that platinum is PT. And now it tells us, because it's a transition metal, we have to look for the Roman numerals, and it tells us that it has 4 valence electrons it's going to lose. Manganate is going to be MnO4 with a -2 charge. Okay, so the other way we can look at this is crisscrossing our electrons. So bring the 4 down here, bring the 2 down here, and it becomes PT2 MnO4 4 to balance out those charges. But if we look at this one, both of these guys are even numbers. So technically we didn't need all of those elements to make our compound. We really only needed 1 platinum and 2 manganates to make our compound. So this is the answer we would be looking for. The next one is NH4Br. And since there's 3 capital letters, we know it has to have a polyatomic ion in it, even though they're all nonmetals. And so the polyatomic ion is this one right here, which is ammonium. So we can put ammonium down. Oh. And then we have Br, which is bromine. But we got to change the ending to bromide. So it becomes ammonium bromide. The next one is oxygen and fluorine. So it's oxygen and fluorine. Oxygen again is the first one, and there's only 1, so it becomes oxygen. Fluorine, there are 2, so it becomes di, and then again, it's fluoride. And last but not least, we have nitrogen, so it's N, and there's only 1, and oxygen, which is O, and there are 2. So it becomes NO2. If you have any other questions about this one, let me know.